We are looking at uniform distributions. It's day 17. So this is a probability distribution where in a single trial, all the outcomes are equally likely. So here's another thing. It says for a uniform distribution, for every outcome, the outcome is 1 over n, where n is the total number, the number of possible outcomes in the experiment. So let's take a look at what that means. We have flipping a coin as an example. Let's clear this page. We have flipping a coin as an example. So in a single trial, all the outcomes are equally likely. So heads is equally likely to tails. So that would be an example of PXI. PX1 would be heads, right? Would be equal 1 over 2 possible outcomes. That's probability of heads, and the probability of tails, that would be X2, right? Over here would be 1 over 2 as well. So because there are n equals 2 possible outcomes. So here's how the probability distribution will look. As you can see, they're all equal. It's a flat distribution. So another example is rolling of 1 dice. Now let's bring that back to this example. This right here. Rolling a single die. In a single trial, rolling a dice, all outcomes are equally likely. So 1, 2, 3, 4, 5, and 6 are all equally likely. And there's 6 possible outcomes. So n is the number of possible outcomes. N equals 6. So then P of any particular value, xi, x1 could be equal to 1, x2 is equal to, 1 rolled, 2 rolled, right? X is the random variable and it can take on any values. x3 ... x6, 6 rolled. So probability of any one of these, right? Probability of x1 is equal to 1 over n, which is 1 over 6. Probability of x2, or 2 rolled, is 1 over 6. Basically, when they're all equal, they have the same probability of happening. So, rolling of 1 dice, once again, that's equal to 1 over 6. Right there, it's an equal likelihood of each of these random outcomes. Okay, so part of uniform distribution is saying, well, which spinner here has a uniform distribution? And if you look at it, you can pretty much tell right away. But it depends, right? Distribution of a spinner 1, of spinner 1, that's spinner 1, by number. And as you can see, the probability of scoring 1, right, there's 3 1s. So it's 3 out of 8. And the probability of getting a 2 is a bit less. There's only 2. And then 3, 4, and 5, over that part, it looks uniform, but it's not a uniform distribution by number. And when we look at spinner 2, our distributions are it's also not uniform because the outcome of yellow and blue might be the same, okay, a quarter each, but the distribution of green is, it's a bit more likely that it'd be green and less likely that it'd be red. Okay, but looking at spinner 1 by color, we see that they all have an equal likelihood of occurring, and therefore it has a uniform distribution. And we could call it a flat distribution as well. Now, how does when you have a uniform distribution, how does expected value work? So normally expected value is, right? We take all values, all outcomes, and you multiply every outcome by the probability of that outcome. Sorry, you multiply every outcome by the probability of that outcome, and then you add them all up. That's what this means. Add them up. Okay, so for a uniform distribution, the probability of all of them are the same for all xi. So we can replace that over there with 1 over n for every single one. So we have 1 over n times xi. So when calculating expected value for a uniform distribution, you can factor out 1 over n. So essentially what this means is, so you can take this out. So essentially how that works is, let's just show you. Let's say there's 3 values of xi. Let's say it goes from 1 to 3, right? So e of x is equal to x1 times 1 over n plus x2 times 1 over n. Whoops. Plus x3 times 1 over n, right? So what that means is I can factor out this 1 over n, right? I can say 1 over n, because it's a common factor for all of them. I say 1 over n times x1 plus x2 plus x3. Now this is just an example. Where did I get the 3? I just threw that in as an example to say, pretend we have only 3 terms. Oops. How do I undo? I don't think I can. So x1, 1 over n, plus x2, 1 over n, plus x3. We're going to pretend there's a 3. N is 3. 1 over n. We're just pretending that it is, okay? And that, if we factor it out, that becomes x1 plus x2 plus x3, right? And then that's equal to 1 over n times, oops. Times I equals 1 to 3 xi, right? That's equal to this, right? Xi, add up xi from 1 to 3. And then that's essentially what that means right there. Okay? So you can factor that out. Now, if you didn't understand that, it's not necessarily... It's not necessarily the worst thing. Just know that I can multiply 1 over n times all my expected values. Okay, so a spinner has 8, this is example 1, 8 equally spaced sectors labeled from 1 to 8. In a particular game, a player wins points equal to double the sector's face value if a power of 2 is spun. So power of 2 gives me double 2 times face value. Okay. For all other spins, a player loses face value. Others minus face value. Is this a fair game? So here are my powers of 2. This is 2 to the 0, 2 to the 1, 2 to the square, and 2 cube. Okay, so let's do expected value. What's expected value mean? Well, the probability of each one of these values is 1 over n. So the expected value is, if we look at the formula from before, let's take a look. It's 1 over n, number of outcomes, multiplied by, add up all the values, all the expected values. So let's go ahead and do that. So for every spin, let's clear my screen. For every spin, if I get a 1, I get double the face value, right? This is xi. My xi is points. So if I get 2, I get double. If I get 3, I get minus 3. If I get 4, I get double. If I get minus 5 is not a power of 2. Neither is 6. Neither is 7. And 8 is a power of 2, so I get double the face value. Okay, so you add up all my xi and multiply it by 1 over n. So how do we add? That means sum up all the xi from 1, all of them, right? From 1 to n, all of them. So that's equal to 9. If I add up all these numbers, 2, that's 6, minus 6, that's 5, minus 5, and 16 minus 7 is 9, so that's how I got 9. Basically, you add them up. Okay, and then you multiply it. E of x equals, well, that's 9, 1 over n, times the summation from 1 to n, which means all xi, the sum of all possible values or outcomes in points, and it's 1 over 8 times 9, so I can expect 9 over 8 points for every spin. It is not a fair game. So why is it not a fair game? Well, a fair game is when the expected value is 0. So every spin you can expect to get a certain number of points, right? So if it's 0, it's equally likely that you would lose or win. So because this is a expected value not 0, it is not a fair game. So that's just a definition. A fair game is when expected value is 0. All right, so calculate a game. This is an example for you to try out. Create a game where with each spinner where the game is fair. So even though the probability is different, if you give points or assign points, more points for the less probable outcomes, right? And you kind of weight it a specific way such that E of x equals 0, right? Then that's how you create a fair game. Okay, that's something for you to try. Homework will be posted, and that's the end.